theorems, laws and theorem. Then we discussed about how to represent the Boolean function in different ways. So we discussed about truth table form, SOP, POS, standard SOP, and standard POS. Okay. So we discussed about this much. So just a quick recap because we will require those things. So if I'll write a function equal to AB, B bar D. So this is in which form? This expression SOP, POS, sum of product. Then out of sum of product, two things are possible. Sum of product, standard SOP. It is in which form?
Non-standard.
It is only sum of product. It is not in a standard form because how many variables are there? This function consists of how many variables?
3.
Three. A, B, D. Okay. So, but each term contains only two variables, so it is not in a standard form. Okay. So the standard form is very much useful. First of all, SOP is useful. SOP and POS is useful. Out of that, if we'll convert that into a standard form, it will become more powerful. So we will see that. We also quickly discussed that day about the what is the utility. Okay. So that same example. Suppose if I will find out f equal to a bar b plus b bar c plus a bar c. What I need to do? This function consists of three variables a, b, c. Then how can I find out this f? For that purpose, I will require what? I will require a bar, b bar. Then what to do? You will find out a bar dot b. Then you will find out b bar dot c. Then you will find out a bar dot c. Then you add all them. Then you will get f. Okay. So to find this f, what I need to do? I need to find out this first, this one, third, fourth, fifth. Then in the sixth step, I can find out this function. So it will become lengthier. This thing will become lengthier. This is easy, but we need to solve this. It will require time. So how to minimize the time and how to directly write this f? Without finding everything, how to directly write that f? So for that purpose, first of all, this f has to be in either in standard SOP form or it has to be in standard POS form. Okay, so if I can convert them into either standard SOP or standard POS, then I can directly write about this f. So we'll see that how we can do that. Now, to understand that, first we need to understand this mean term and max term. Okay. Once we understand that, then we'll be able to write down that f. We'll be directly able to find out that f. Now think that I have two inputs A and B. Okay. If I have two inputs A and B, okay. First of all, how many product terms will be possible out of this? How many product terms will be possible? With the help of A and B, how many product terms are four are possible? What are those?
A B, A dash B.
A bar, B bar, A bar dot B, A dot B bar, A dot B. Now suppose I have three inputs A, B, C. When I'm saying input means its complement is also available. Okay. So if I have three input A, B, C, how many product terms will be possible?
8.
More product terms are possible. AB can also be product term. A bar, B bar is also a product term. So how many standard product terms are possible? Standard product term means consist of all inputs A, B, C.
8 standard.
8 standard product terms are possible. Product terms will be more because we can create product terms consist of AB only, BC only, AC only. So multiple are possible. But standard possibilities are 8. A bar, B bar, C bar, A bar, B bar, C, So these 8 product terms are possible. Apart from this, anything else possible? Or this 8 only?
This
This 8
item.
only, this 8 only possible. Okay. Similarly, if I'll go for 4 inputs A, B, C, D, then if I'll go for 4 inputs A, B,
16.
C, D, 16
16.
standard product terms will be possible. Standard product terms. Standard product terms. So the standard product terms are called as mean terms. Standard product terms are called as mean terms. Okay. So now let us concentrate only on this. First of all, let us concentrate on this 2 input standard product terms. So I have 2 inputs A and B. So how many input combinations will be possible? A can take 2 values 0 and 1. B can take 2 values 0 and 1. So how many combinations will be possible out of those AB? How many
4.
combinations will be possible? 4 possible combinations. They can be 0, 0, 0, 1, 1, 0, 1, 1. Now, these 4 product terms are possible. So next what I am doing, I am writing them. Okay. So next you find out A bar, B bar. What will be A bar, B bar? Is it correct? Whatever is mentioned. ठीक है, A bar, B bar. Is it correct?
Yes, sir.
Similarly, A bar, B,
Yes, sir. Yes, sir.
A, B bar, and A, B.
Yes, sir.
Okay. Now, out of those product terms, see this. There are any similarity? Any pattern is there?
Yes, sir.
What is the pattern?
In the diagonal terms, one are there.
Okay. So you can say that diagonally they are 1. You can also refer that, you can infer from that, these product terms are 1 only for a particular combination. They are 1 only for a particular combination. For other combinations, these outputs are 0. For other combinations, these outputs are 0. This is 1 A bar B bar 1 only for 0 0. For other combination, this output is 0. Similarly, A bar B, this is 1 only for 0 1. For other combinations, this output is 0. Similarly, A B bar, this is 1 only for this input 1 0. For other combinations, output is 0. Similarly, AB is 1 only for double 1 input. For other inputs, this output is 0. So if I write same thing here, so I will just write what will be, they will be 1 for which? They will be 1 second. They will be 1 for AB equal to, A bar B bar equal to, this is 0 0, when 0 1, then 1 0, then 1 1. Up to this, is it clear? Up to this, is it
Yes,
clear?
sir.
Okay. Now, here if you compare, can you tell what will be the value? Just compare this now. Can you tell what will be the value of A? Just see this corresponding values and tell what will be A and what will be B. A should be 1, B should be 1, A bar should be 0, B bar should be 0. Accordingly, I wrote this. See, this 0 0 means this is 0 0. It is 0 1 means 0 1. It is 1 0. This is 1 1. Okay. That means if any variable is present, in on complement form, that value will be 1. If it is in complement form, that value will be 0. Okay. So without solving all this, I can directly from this formula, I can directly write about this for which combination output will be equal to 1. Similarly, for same example, if I will extend for this ABC, okay, can you tell for which combination this output will be 1 using this formula?
1 0 0.
1 0 0. You can verify. Okay. I guess it is not there. So you can verify that. Okay. Similarly, this one, A bar B C bar. A bar means complement form
0 1 0.
0 1 0. Okay. Now, so up to this is clear. Up to this, any doubt, anyone? Then how we'll use this to solve our problem? How I can directly write the f? So out of everything, just I need to remember this. When I am discussing about this mean terms, x should be 1, x bar should be 0. Okay. Now, tell me any one function f. Suppose here I am writing. Suppose f is equal to a bar b bar plus ab. Okay. Now what happens? Basically, when I am dealing with these product terms in SOP, standard SOP, what we are doing? We are adding this product terms. We are adding this product terms. So when we'll do logical addition, what happens? What is the definition of this OR gates? When you are adding, what is the definition behind that? When your output will be 1. Basically, this SOP, you are adding this product terms only. Like this example, you are adding A bar B bar with AB. So when you add 2, what happens? When your output will be equal to 1. What is the definition?
So if anyone is 1.
If any input is equal to 1. Okay. So when a function I will represent in the standard SOP form, what happens? Each product term will remain 1 only for a particular combination. As you can see here, they will be 1 for a particular combination. So when you will add them for those particular combinations, output should be equal to 1. Your output should be equal to 1. So what will happen? Without solving anything, as it is A bar B bar is there, A bar B bar means what? 0 0. For that combination, my output should be 1. AB means what? 1 1. So this combination should be 1. Other combinations, this output should be 0. Because that is the property of a OR gate. When any of the one input is equal to 1, then your output will be 1. And each product term will 1 for a particular combination. So without knowing anything, if I can represent a function in standard form, okay, then I can directly write that function. Okay. So now, suppose I will tell you this. 1 second. Let me write. So maybe 2 variable you will not be able to analyze its importance. But suppose we'll go to 3 inputs. Now ABC. Suppose I will write this as A bar B bar C plus A B bar C bar A B bar C plus ABC. So if I have 3 inputs, then 8 possible combinations are there. Okay. So can you directly write this function f without
Yes.
solving anything? What will happen? Just I need to check a bar it is in a complement form. So this value should be 0. B bar is in complement form. This value should be 0. No complement. This should be 1. A is in not in complement. So A should be 1. B bar complement. This should be 0. C bar complement form. This should be 0. A not complement. So 1. B bar 0. C 1. A 1. B 1. C 1. So for this particular combinations, my output will be 1. My output will be 1. So 0 0 1, output is 1. 1 0 0, output is 1. 1 0 1, output will be 1. 1 1 1, output will be 0. For other combinations, output will be 0. So now you can see, directly I am able to write this function. Directly I am able to write this function without solving it. I didn't solve this. I didn't find out A bar, B bar. if I don't know this procedure, what I need to do? I need to, how many columns I need to write? I need to find out A bar, B bar, C bar. Then I will write A bar, B bar, C, one column. A, B bar, C bar, one column. A, B bar, C, one column. A, B, C, one column. So how many columns I need to write? I need to write 7 columns. I need to solve those things. It will become lengthier. So instead of that, I am directly able to find this. I am directly able to find this. Okay. So each of these product terms are called as mean term. Each of these product terms are called as mean term. So there is a particular notation is used for that. One second. Okay. So what happens? A bar B bar is 0 0. A bar B is 0 1. AB bar is 1 0. AB is 1 1. Okay. So what is the decimal equivalent of 0 0? Decimal equivalent of 0 0?
0.
0. So we'll denote this A bar B bar as small subscript 0. Small m stands for mean term. So small m0. 0 1's decimal equivalent 1. So we'll denote this as small m1. AB bar will denote this as m2. AB will denote this as m3. So now suppose I will write a function A bar B bar plus A bar B plus AB bar. Suppose this is given. Okay. So what is A bar B bar in terms of mean terms? M0 to M3. A bar B bar क्या है? What is A bar B bar? Just check this and tell.
M0.
M0. So I can write this also as M0 plus. What is A bar B? A bar B is M1. AB bar is M2. So we can write like this, or as their addition, I can write this as summation of M. Then I need to write this subscripts 0, 1, 2. Okay. So functions can represent either like this, this, or this. Okay. So anything, any way we can represent. That means question can be given in any way, maybe in this format, this form, or this form. Okay. Now, let me go through another example. Similarly, for 3 inputs, how many mean terms will get? 8 mean terms. A bar, B bar, C bar. This will be small. Let it written there. Directly go to that. One second. Okay. So it is mentioned in terms of X, Y, Z. So X bar, Y bar, Z bar is M0. X bar, Y bar, Z is M1. X bar, Y, Z bar is M2. X bar, Y, Z is M3. X, Y bar, Z bar is M4. X, Y bar, Z is M5. X, Y, Z bar is M6. X, Y, Z is M7. Okay. So how to remember? Just remember 2 things. When we are dealing with this mean terms, X should be equal to 1. Its complement value should be equal to 0. So whatever your product terms will come, suppose it comes A bar, B bar, C. So what will be A bar? It is in complement form. So this value will be 0. B bar, complement. This should be 0. C, not complement. This should be 1. 0, 0, 1's decimal equivalent 1. So this must be small m1. Okay. Now can you tell what will be this? A bar, B bar, C, D. What should be A bar, B bar, C, D?
M3.
It should be M3 because this is 0, this is 0, these two are 1, 1. So this must be M3. Now suppose A, B bar, C, D bar. This will be?
M10.
This is 1, complement 0, no complement 1, complement 0. Decimal equivalent is 10. So this should be M10. Now, let us do a reverse question. Now suppose, understand this one, this is very, very critical. This is very, very important. Throughout our digital, we'll require this mean terms and max terms. Okay. So now suppose question is given, f is equal to summation of m 1, 2, 7. Okay. That means how many inputs are there? 3 inputs are there.
Three.
A, B, C. So let me write all the input combinations. Okay. So this is F. Okay. So what will happen? First of all, what will be this? How to write? This is 1 to 7. 1 to 7 means what? This is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Okay. So which combinations output will be 1? This combination. Output क्या होगा? This one, first one?
0.
0. 1 corresponding should be 1. 2 corresponding should be 1. 7 corresponding should be 1. Other should be 0. Suppose I will write F2 equal to summation of M 0, 5, 6, 3. Then what will happen? What will be F2? क्या होगा serially?
1.
1.
0, 1.
No, उसके बाद 1 नहीं आएगा. ये 0, 1 उसके बाद 2 है.
So 0, 0, 1. Yes.
0, 0, 1.
Then 0, 1.
Next 0, 1, 1.
1, 1, 0.
If you are not comfortable, just write this thing. Okay. Then that corresponding write 1. 0 means this is 1. 3 means this is 1. 5 means this is 1. 6 means this is 1. Okay. So this is all about the mean terms. This is all about the mean terms. Next, its counterpart will be called as maxterm. Okay. So maxterm means यहाँ पे हमने क्या किया था? We have gone for the product terms. So its counterpart will be what? They will be sum term. One second, let me write. Okay. Now, if I have two inputs A and B, then how many standard sum terms are possible? How many standard sum terms are possible?
4.
4. They can be A plus B, A plus B bar, A bar plus B, A bar plus B bar. Similarly, if I have 3 inputs A, B, C, then how many sum terms are possible?
8.
8. A plus B plus C, A plus B plus C bar, A plus B bar plus C, A plus B bar plus C bar, A bar plus B plus C, A bar plus B plus C bar, and A bar plus B bar plus C bar. These 8 sum terms are possible. Okay. Now check this. In this table, AB is there and all the sum terms are calculated. So what is A plus B? This will be 0, 1, 1. A plus B bar 1, 0, 1, 1. A bar plus B 1, 1, 0, 1. A plus B bar 1, 1, 1, 0. Okay. So is it correct? Verify first.
Yes, sir.
It is correct. Now, what pattern is followed here? Like in case of product terms, one output was 1, other outputs were 0. Similarly, here what happens?
So one output is 0 and others are 1.
Here one output is 0, other outputs are 1. One output is 0, other outputs are 1. Okay. So when we are dealing with sum terms, what happens? Expression will be in terms of standard product of sum. Standard product of sum. So what happens here? Your sum terms will be multiplied. Sum terms will be multiplied. Multiplied means it is nothing but a AND gate, logical multiplication. So when we'll go for AND gate, what is the definition of AND gate? What happens in AND gate? What is the definition?
If any one of the input is 0, then the output will be 0.
If one of the any input is equal to 0, then output will be equal to 0. And precisely what happens here? All the sum terms they are 0 for a particular combination. This is 0 for this combination. This is 0 for this combination. This is 0 for this combination. For this combination, A bar plus B bar is 0. Okay. So what happens? When we multiply them at any time, only one of the input will be equal to 0. If one of the input is 0, then output will be 0. Then this will be helpful for us. Like we discussed about mean term, this is also helpful. So what happens here? These sum terms, standard sum terms, are called as max terms. Okay. Now, if we'll just compare this, these sum terms are 0 for which combination? A plus B is 0 for which combination?
0, 0.
0, 0. A plus B bar?
0, 1.
0, 1. A bar plus B?
1, 0.
1, 0. A bar plus B bar?
1, 1.
Now if we'll just compare them, can you tell what should be the value of A? What should be the value of A bar?
Value of A is 0.
A is 0,
should be
A
0,
bar 1.
A bar should be 1. So it is just the opposite what we did in case of mean terms. In mean term, what we did? X should be 1, X bar should be 0. In that way we can remember. Similarly, in case of max term, your X should be 0, X bar should be 1. Okay. So now, let us just extend this to 3 variable. Now, it is A plus B plus C. So for which combination your output will be 0? A, it is not in complement form. क्या होगा?
0,
A will be 0 or 1? This one. Just check this and tell. क्या होना चाहिए?
0, 0.
It is not in complement form, so all this will be 0. A plus B plus C bar. A 0, B 0. C is in complement form, this should be 1. Next, A not complement, B bar complement, C not complement. A not complement, B bar complement, C bar complement. A bar 1. B not complement 0. C not complement 0. A bar complement 1. B not complement 0. C bar complement 1. A bar B bar complement. C not complement. A bar B bar C bar all are complement. So they are called as triple 1. Okay. So again this 0 0. Now just let us check this upper one. 0 0 is how much? This is decimal equivalent is 0. So we'll represent this max terms as capital M. So capital M 0 0, this will be M0. This will be M1. This will be M2. This will be M3. Similarly, this A plus B plus C, this will be capital M0, capital M1, capital M2, capital M3, M4, M5, M6, M7. Okay. So in this way, we can represent this max terms. Now, how they will help us in finding out? Now, suppose I will write a function A B 0 0 0 1 1 0 1 1. Now suppose my function is A plus B into A bar plus B. Okay. So how much will be A plus B? A is how much? 0 or 1?
0.
A is 0. B is also 0. A bar is 1. B is 0. So that corresponding output should be 0. When we are dealing with POS, we know that if any of the one input is 0, output will be 0. For this A plus B, they will 0 for this double 0 combination. So this should be 0. 1 0 combination should be 0. Other combination should be 1. We can also write this as capital M0 dot capital M2. Okay. Let's take another example. Now suppose f is equal to a plus b bar into a bar plus b into a bar plus b bar. Then tell me what will be the output in this column. What I should write? a plus b bar क्या
1 0 0 0
0 0 नहीं, फास्ट वाला 0 नहीं होगा.
1 then 3
1
zeros.
then 3 zeros. Why? A plus b bar. A plus b bar is what? Let me write it here. A plus b bar, a bar plus b, a bar plus b bar. A plus b bar means what? This is 0 1. A bar plus b, this is 1 0. A bar plus b bar, this is 1 1. So this will be m1, m2, m3. So I can write this function as, they are in product form. So product term, we can write this as pi. Pi of capital M, comma 1, comma 2, comma 3. But remember, they will be helpful, they will be useful only when this function will be in the standard form. If it is not in a standard form, first we need to convert it into a standard form. Otherwise, we'll not be able to find out. So our task is to be first convert it into a standard form. Similarly, suppose function is given as summation pi of m, f is equal to pi of m 0, 3, 5, 7. Then what will happen to the output? Can you tell? क्या होना चाहिए? So for this
0 1 1 0
0 1 1
0
0, then
1 0
1 0,
1 0
then 1 0.
1 0.
Nothing to think, just if you are not comfortable, just write here 0 to 7. Whatever comes in this pi form, those corresponding output should be 0. 0 should be 0, 3 should be 0, 5 should be 0, 7 should be 0. Okay? In this way you can find out. Now, if I'll give you a reverse task, okay. Now suppose this truth table is given. From that, can you write the function? From truth table, can you write the function?
Yes, sir.
Now
Yes,
this
sir.
truth table is given. Okay. So what can I write? F is equal to pi of capital M. Again, just the reverse task. We need to check where corresponding zeros are there. So it will be 0, 3, 5, 7. Similarly, I can write this in terms of standard SOP also. Ones are there. I can write in terms of standard SOP. So can I write
Yes,
in
sir.
terms of summation of M? What can I write?
Yes, sir.
क्या होगा?
1 2 4
1 2.
1 2
4
4
6
6.
So इसमें कुछ सिमिलरिटी दिख रहा है? Any correlation?
Yes.
Whatever terms are missing here, same thing is available here. That is what it is. Okay. When you are dealing with when you are dealing with standard SOP function, okay, basically you are checking ones, and here you are checking zeros. So whatever will not be 1, that has to be 0. Okay. So if I'll write a function f is equal to summation of m 0 5 0 5 6. So can you write what will be pi of capital M? क्या होना चाहिए?
1 2 3 4
2 are missing,
7
1 is missing, 2 is missing, 3 is missing, then
4.
4 is missing, then 7. 1 2 3
Yes,
4
sir.
7. Okay. So same example is given here. Okay. Let us do one by one. Suppose this example is given, this function is given. Okay. So I want to write down this function. Okay. So first of all, what can I write? F1 in terms of summation of M. I will write here 0, 1, 2, 3, 4, 5, 6, 7 because accordingly I arranged it. Okay. Then For which combinations my output is 1,
1,
1, 2, 4, 6.
2, then 4, 6. Now, it is in the standard SOP form. When we are dealing with SOP form, we know that x bar is 0, x is 1. So 1 means what? 1 means 0, 0, 1. 2 means 0, 1, 0. 4 means 1, 0, 0. 6 means 1, 1, 0. Okay. So what will happen to that function? That function will be 0, 0, 1 means what? It is in 0 means complement form. So A bar, B bar, C
C.
plus. This will be
A bar B C bar.
C bar plus A, B bar, C bar plus
A B C bar.
Okay. Similarly, if I write this in terms of pi of capital M, what can I write? Either you can write
0 3
you can check
5
from
7
here
3 5
or 1
7.
already calculated. So 0, 3, 5, 7. Now we are dealing with POS. When we are dealing with POS, X should be 0,
0.
X plus should be 1. So when I am writing 0, this should be 000. 3 means 011. 5 means 101. 7 means 111. So क्या लिख सकते हैं? Now it is a sum term. It will be an addition. So 0 means what can I write? A plus B plus C. A plus B bar plus C bar. Dot. Then A bar plus B.
B plus C bar.
Then A bar plus B bar plus C bar. Okay. Is it clear up to this?
Yes, sir. Yes.
So this will be very much useful. Okay. Last thing.
Sir, I had a question.
Yes.
Sir, suppose it is written summation of m1, 2. So, sir, how will we know the number of variables involved in this?
Okay. So if it is not mentioned, it is only mentioned 1, 2. Okay. Nothing is mentioned. So 1, 2. So can it be? It has to be how many variables? Minimum is how many variables required to go for 1 to 2?
Sir, 2.
2. So we will go for 2 inputs. So whatever is minimum, you will go for. If it is not mentioned, whatever is minimum, you will go for that. Okay.
Okay,
Now,
sir. Thank
last
you.
thing. What is our small m0? Midterm small m0. Just consider this only. Check this table. Okay. What is small m0? Small m0 is x bar, y bar, z bar. Okay. What is capital M0? X plus y plus z. Okay. If I'll take m0's complement, what will be complement of this? X bar, y bar, z bar's complement. Applying De Morgan's theorem, what can I write?
X plus Y plus Z.
Plus y double complement plus z double complement, which is nothing but x plus y plus z. So what happens? The small m0's complement is capital M0. Similarly, you can prove for others. Okay, so you can write that small mi's complement will be equal to capital Mi. Okay, so you do that one. Okay, so this thing we discussed. Okay, so replace. You've already done this. Suppose function is given in SOP form, so we can find out POS form from this. Okay, so do one thing. I will share this PPT. Okay, so you will go through that. Let me share now only. So you will go through that. Okay, so next class we'll go for the others because it will be very much required. So practice it. Okay, so we'll see that in the next class.
Okay, sir.
1 second, let me share the PPT.